Welcome to The Explainer. I'm absolutely thrilled to have you here today. If you're a focused learner who loves breaking down complex information into clear, actionable visual roadmaps, well, you are in the exact right place. Today, we're taking something that usually looks like a dense, overwhelming document, a university syllabus, and we're transforming it into an exciting, highly strategic 4-year roadmap. We are going to look at how a modern education in technology is engineered literally from the ground up to create industry-ready innovators.
To really ground our exploration today, we're zooming in specifically on the Department of Computer Science and Engineering at Vishnu Women's University. What we're analyzing is their highly anticipated, forward-looking R26 course structure, which kicks in for the 2026 to 2027 academic year. Now, this isn't just a list of classes. It is a literal blueprint for the future of tech education.
Okay, let's dive into this. Here is our agenda for mapping out this 4-year hero's journey. First up, laying the technical foundation, then building core computing skills, mastering the cutting edge, launching into the industry, and finally, expanding beyond the major.
So here's a macro view of the chronological path a student actually takes. You can really see how the curriculum is designed to level up their skills year by year. It's this beautifully orchestrated progression from basic principles all the way up to a full-fledged industry launch over the course of 4 years.
All right, let's kick things off with Section 1, laying the technical foundation in Year 1.
You know, any great architect will tell you that a skyscraper is only as strong as its bedrock, and software engineering is exactly the same way. Year 1 perfectly balances two completely different types of foundational learning. On one side, you've got this massive scientific scaffolding, linear algebra, principles of modern physics, and differential equations. That's the heavy math and science you absolutely need to understand how computers physically and logically work. But right alongside that, students are taking their very first steps into actual coding with C programming, Python, and data structures. So they aren't just sitting there learning theory, they've got their hands on keyboards from semester 1.
Moving right along to Section 2, building core computing skills in Year 2.
So, the foundation is set, and now the narrative shifts to constructing the real structural frame of modern software engineering. We see a massive jump into core subjects here: operating systems, full-stack development, object-oriented programming with Java, computer networks, and database management systems. This is that moment where students truly awaken to the fundamental building blocks of tech. They start actually seeing how a network talks to a database, or how a user interface hooks up to a server.
Now, what's really fascinating here is the modern edge of this syllabus. Tucked right into the second semester of Year 2 is a course called Foundations of AI and ML. I mean, the curriculum doesn't wait until senior year to bring up artificial intelligence. It drops this brilliant teaser right in the middle of their core skills training, totally prepping their mindset for the advanced tech that's waiting for them.
But hey, here's a number you absolutely cannot ignore: 2. Right after Year 2, students face a mandatory 2-month summer internship. The university flat out refuses to let students stay purely academic. They're pushing them out into the real world to actually execute what they've just learned.
Which brings us to Section 3, mastering the cutting edge in Year 3.
If Year 2 was the structural frame, well, Year 3 is the absolute climax of our technical narrative. The curriculum takes this massive, unapologetic leap directly into the future of computing. We're talking specific courses like generative AI and LLMs, right alongside quantum computing fundamentals. These aren't just obscure concepts that might be relevant in 10 years. They are the ultra-modern, cutting-edge technologies that are reshaping the world right now. And having them as core requirements, that really sets this syllabus apart from your standard traditional program.
Year 3 is also where this idea of progressive disclosure really kicks in with professional electives. Students finally get to choose their own architectural finishing touches. They can branch into an AI and data track with electives like reinforcement learning and natural language processing, or they can totally pivot over to security and design with cybersecurity and AR/VR immersive design. It's all about specializing at this point.
And look, once again, that powerful number returns. Year 3 wraps up with another mandatory 2-month summer internship. It's this continuous, deliberate rhythm, right? Learn the theory, apply it in the real world, and then return to learn more theory. It completely anchors their education in actual day-to-day industry practice.
All right, hitting the home stretch. Section 4, launching into the industry in Year 4.
So, in this final year, the focus completely shifts to bridging that gap between academia and a full-on professional career. Just look at these job-oriented electives being offered: DevOps, Spring Boot, Power BI, high-performance computing with CUDA, AWS, and Azure. Now, why does this matter? Because these are definitely not your old-school theoretical computer science classes. These are the exact specific tool sets that tech companies are putting on their job descriptions today. The curriculum is directly answering the real-world demands of the modern tech industry.
Which leads us to this stark number: 6. The entire final semester of Year 4 is dedicated to a massive 6-month major project, 10 whole credits. This is it. It's the ultimate industry readiness test where students basically have to synthesize absolutely everything they've learned over the last 4 years into one single comprehensive technological achievement.
And finally, Section 5, expanding beyond the major with minors and open electives.
Now, let's open up the narrative to the rest of the university, because it's fascinating to see how this powerful tech knowledge is integrated for students outside the computer science department. There is this incredibly extensive list of courses available for non-majors who are seeking a minor degree in computer science. A student majoring in something completely different can still take basics of deep learning, cloud computing, or even information security.
And honestly, the process is super structured and accessible. It's just a straightforward 2-step formula. Step 1, a non-CSE student chooses any 4 courses from that extensive list. Step 2, they complete 2 massive open online courses, or MOOCs. By just knocking out those 2 steps, they earn a minor degree. That is going to make them highly competitive in a job market that is entirely driven by tech.
We also have open electives. We're talking courses like Artificial Intelligence for Engineers or Generative AI and Prompt Engineering offered straight to other departments. I think this brilliantly illustrates a core philosophy here. In this current tech revolution, absolutely no discipline gets left behind. Understanding AI and data? It's really no longer just for the software engineers. It's becoming a mandatory skill for everyone, no matter your field.
Which brings us to the end of our explainer with one final big question for you. How will you architect your own journey through this futuristic tech landscape? You know, whether you're a student, an educator, or a seasoned professional, looking at a highly optimized roadmap like this R26 curriculum shows us exactly where the future of technology is heading. The tools are all right there, from quantum computing to generative AI. So the only question left is, what are you going to build with them? Thank you so much for learning with me today, and I'll catch you in the next explainer.